And we are live. Hello and welcome to our virtual Lunch and Learn. Today we are talking about machine guarding, understanding the proper application of the minor servicing exception. My name is Rachel Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. Presenting for us today is Tom Alford, TUV Certified Functional Safety Engineer with Rockwell Automation. He's joining us today from his office in Columbus, Ohio. Out in the comments section, ready to answer your questions, is Jim Birdie, Systems Consultant with McNaughton-McKay. He is also out of Columbus, Ohio. We'll also have a Q&A portion at the end so that Tom can answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for the attendees to join us. As you come in, let us know where you're tuning in from in the comments section. As we continue to socially distance, we're happy to be able to host these live sessions here on YouTube and make it possible for you to be able to join us from the comfort and safety of your homes and offices. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. And we'll be continuing this series every Wednesday at noon, so be sure to join us on your lunch break. Hi, Tom. Thanks for joining.
Well, thank you for inviting me.
And yes, for anyone just joining us, welcome to the Virtual Lunch and Learn Machine Guarding. Let us know where you're joining from in the comments. Hi, Mike. Hi, Leanne. We'll be looking for questions as you have them in the comments while our presenter, Tom Alford, presents alternative measures that can meet requirements and significantly improve productivity at the same time. Our specialist, Jim Birdie, will do his best to respond to your questions in the comments as we go along. And we'll also have a Q&A segment at the end of Tom's presentation to address some of those questions in more depth and to allow some time for any follow-up questions you might have. If you'd like to reach out afterwards, or if you have further questions for Tom, you can send us an email at mcmclive@mc-mc.com. You can see that email address there on the screen. Be sure to let us know which session you attended, and we'll direct your questions to Tom. We'll also have that email address available at the end of today's session. All right, Tom, it looks like we have quite a few attendees, so let's go ahead and get started.
Awesome. Thank you, Rachel. Once again, thank you for the opportunity to present and lead this training session and this discussion. Hopefully, folks will engage, ask questions, and maybe even make comments along the way. But we're going to be talking about a very important topic, which is machine guarding, and specifically as it applies to proper application of the minor servicing exception. Before I go much further, I do also want to thank the McNaughton-McKay team for hosting this webinar series during this time. I mean, I think this is awesome. It's they've done a great job of putting this together and lining up speakers. And I just want to thank them for reaching out and offering folks some really good content that they can use and then reference later through their YouTube channel. So I appreciate that, McNaughton-McKay. So as we get into this, kind of like to start out with a little bit of around, why is this important? Why are we gathered here? We're going to spend this time investing an hour to go through this topic. And, there's a lot of reasons, but the three main reasons that I want to focus on is, one, it's the law. Okay. What we're going to discuss today is covered under Code of Federal Regulations 29 and 1910. And so, there's a legal requirement here that's an important element of this. There's also, it's good business. I mean, it's been proven over and over again, not just in, the form of improved employee retention, better culture, but it's also been shown that companies that have effective safety programs and effective safeguarding implementations generally have better OEE scores. And that's a tangible number. And I've seen a lot of research done in that area, and it's very consistent that you don't have to trade one for the other. And generally, those same principles around reliability and root cause failure analysis that drive a very lean and optimal manufacturing environment are key to safety as well. And I think we'll see more of that as we move on. And then thirdly, this is something that I always try to keep in mind is, failure to do this correctly can have very serious and irreversible consequences. If you're in the safety space, when you're there, when we fail, there can be very serious, immediate consequences, and I always try to keep that in mind. So those are kind of the three things. You may have some others, you may throw them in along the way, and we'll talk about them. Hopefully, have time as well. We'll get to the chat section. So, going through this today, I'm going to so the context of our conversation today from find in OSHA 29 CFR 1910.147. I think probably everybody here is very familiar with the control of hazardous energy requirements, also known as lockout requirements. And I'm not going to read these to you. You're probably well versed in them, and you can use the reference I have here later. But there's a couple of things that are important I want to emphasize here, and one is that this doesn't cover normal production operations. You see there; those are covered by Subpart O. And at the end, there is an exception to the paragraph about where you say note exception paragraph A2 II talks about minor tool changes and adjustments. So we'll be digging a little bit deeper into this. In summary, one thing we want to be very, very clear about that can get lost in these discussions about the minor or alternative method of protection is that lockout tagout is the default position for servicing and maintenance. Okay, that's it. And personally, I had that driven home by an OSHA field representative that has retired several years ago, but earlier in my career, he was a great mentor, and I could sense sometimes he got frustrated with me when I was talking to him about light curtains and cool things you could do there and laser scanners and all this stuff. And finally one day he just shut me down. He said, "Tom," he said, "you don't get it." He said, "You technologists want to wave your technology wand at everything," and he said, "that is not the approach." He said, "You've got to earn it." And I'm sitting there, earn it? What do you mean? What do you mean, Jim? I got to earn it. He said, "What is the safe state of a machine?" I said, "Okay, the safest state is de-energized." Okay, but that doesn't do anybody any good. And he goes, "Yeah, that's right. A de-energized machine doesn't have utility, does it?" I go, "No." And he says, "So what allowance is there for?" I'm like, "Okay, Subpart O." And he goes, "That's right, for the point of operation." And he said, he said, start with in mind, the safe state is de-energized, and anything that I do, and whether it's guarding around point of operation or minor servicing, he said, make sure you earn it, that you can demonstrate why the approach that you're using is necessary, and you can justify it. And I kind of hit home when I say, and it really did change the way I approach machine guarding and safety completely. And I'm always thankful. One thing in the safety space, mentors are extremely valuable, very helpful. Hopefully you're either being mentored or you're mentoring others in this space. So lockout tagout's the default position, but normal operations not covered by the standard for control of hazardous energy, and also minor tool changes and adjustments and other minor servicing, it states here, may be eligible for an exception, but there are very specific conditions for that exception. And that's what we're going to really focus on today, is those very specific conditions, because it's absolutely critical that we understand them. So if we dig in a little deeper on the note that I pointed out earlier, you can see that these exceptions are minor servicing have to occur during normal production, be routine, be repetitive, integral to the operation of the machine, and there must be an alternative measure in place that provides effective protection. All this criteria, in order to use the minor servicing exception, as we often call it here, we have to meet all of these requirements. What I see often with the minor servicing, I tend to see folks fall into one of two groups. There's the group that doesn't take advantage of it at all. I mean, they're scared to death of it, minor servicing, and it invokes fear, and they avoid it. And then unfortunately, there's others, a large group of others that say, oh, minor servicing, I'm going to claim that, with no thought and consideration to the requirements, because you can see here, this exception is detailed, and there's a lot of supporting guidance around what it takes to meet this. And within the normal production, routine, repetitive, integral, and alternative measures, another thing that tends to happen is folks put all their emphasis on, yep, it's occurring during normal production. Yep, it's routine. Yep, it's repetitive and absolutely integral to the operation of the machine, the normal production machine. So I'm going to put a light curtain here. When you look at alternative measures, and this is going to be the real focus of depth today, notice down here highlighted in yellow, you see the word effective protection, alternative measures which provide effective protection. How do we ensure that we provide effective protection? And the word effective here means that it's successful in producing a desired or intended result. Okay. The desired or intended result is keeping the person interfacing with the machine performing the minor servicing task safe. It has to do that. If it fails to do that in any way, it is not effective. So that's an important point as we go through this. So what happens here in minor servicing, we begin to see some overlap of the worlds. There's this case on your left in red where we have a lockout tagout, where the machine must be de-energized completely. And on the right, we recognize that to perform some tasks, the machine must be energized. And there's different criteria. If we're dealing with lockout, tagout, or control of hazardous energy on the left, that's very procedural. You can see the outline of the procedures is required. When we get to performing tasks under energy, it's a different realm, and even the note directs us to subpart O. You can see here that so for machine maintenance falls under 1910.147, 1910 subpart O for production operation, and then minor servicing is bridges and allows for some minor servicing tasks to be performed. But we have to meet criteria, and that criteria, the key part is that effective protection. Because quite honestly, if it's routine, repetitive, integral to the operation of the machine, and it's done during normal production, so what if we don't have an effective means of protection? Okay, this is absolutely the critical piece, and unfortunately, the piece that I don't see folks spend enough time looking at often. why do we want to spend time on this? Why is this important? And one of the reasons that you see common is the financial impact. I mean, lockout, locking out or tagging out takes time, okay? An alternative measure can reduce that time to perform a task, and that can have significant financial impact, okay? So that's one reason people are concerned. But other reasons that we want to look at alternative measures is what about other exposures? I mean, when I go to a panel and I de-energize a panel, I am introduced to potentially other hazards. So we need to look at the bigger picture. So also, is it potential that the alternative method of protection may actually reduce risk in some area? And we also need to look at the reliability of machinery. What impact is our lockout tagout program having on that? So those are some of the reasons why it's important that we look at this. Clarify, make sure we understand what's the law and what's the standards, because I'll get rattling on and apologize and maybe just start spitting out some standards and references. The key thing is federal regulations 29/1910. That is the law. That's what we must do. It's a performance standard. It's the law. Okay. There are several standards, industry standards that we will reference to, such as ANSI's ASSP Z244.1, ANSI B11.0, B11.19. These are industry standards, fall under what's termed as consensus standards. They help us with the how, but they're not the law. So if there's ever a conflict between the standard and what you see in 29 CFR 1910, 29 CFR 1910 is the law, okay? It's the top dog, but it doesn't prescribe exactly how we get to this effective yet. And that's why these standards become real important. Another type of standard that I mentioned here are machine specific, or what are called C-level standards. So you may find, like for robots, for presses, there are servicing tasks that are well documented in there, how to have an effective alternative means of protection when dealing with that specific kind of machinery. Right? ANSI Z244.1 2016 really is a great document that I would encourage you, if you're applying or thinking about applying minor servicing exception, that you invest in getting this document and familiarize yourself with it. It supports everything we're trying to achieve here. The first 7 sections really focus on the control of hazardous energy and making sure that we're not exposing our workers to any type of unexpected startup, things of that nature, dealing with stored energy. And it states here in 7.1, you can see here, lockout tagout shall be used to secure the energy isolated device to control hazardous energy to the machinery, equipment, or process from the energy source. Sorry, I read all that because the key's right here. Lockout shall be the primary method of hazardous energy control. Okay, that's clear. I said it before. I'll say it again. Sorry, but it's important. We've got to earn. Think of it that way. I need to justify. I need to demonstrate practicability. And if I'm going to use the minor servicing. Now, if we get to alternative methods of hazardous energy control, or what sometimes referred to as minor servicing, to use those alternative methods, there are 3 criteria that I'm going to point out here. That'll be the basis of the most of our time. One, I underlined effective. How do you know if it's effective? Effective means it has to work. Well, if I want to work, I'm looking for principles that are tried and true, right? I need to know that I'm using good engineering practices, things that are tried and true, industry standards. That's going to help me, substantiate that I've, achieved an effective measure here. But these 3, and there's a lot of content below these 3 we won't have time to get into today, but hopefully you'll dig into this later, but number one is the practicability. Practicability is a big word, and you'll hear it in the safety context a lot, but it deals with the viability or feasibility. Is it able to be done or put into action? That's really what the practicability is. So you got to practice. Starts with a practicability and justification analysis, then a risk assessment. There's that guy, man. He's always there when we're talking about guarding and risk management, risk reduction. So the risk assessment, and then we look at the other applicable evaluations that are important for an alternative method. So these are three things. Before I'm going to claim that I have an effective alternative method, I need to make sure that I've looked at all three of these areas. And this standard gives us great guidance for that. So the practicability justification analysis. I've got them out here. It starts with assess lockout impacts. What are the impacts of locking out? What's the procedure? Are folks exposed potentially to arc flash hazards? Maybe they're not. Maybe the impact is minimal. We need to look at that. What is it? We don't get we can't justify the use of an alternative method just because the lockout is inconvenient. Okay, so we need to look at the impacts. Look at the impacts that are financial. Look at the impacts on the reliability of the machinery. Starting and stopping machinery, especially if it's excessive, obviously can damage the equipment, right? So this analysis begins by looking at the impacts. It also then goes down to assessing options for minimizing exposure. So are there ways we could do this differently? The task and maybe reduce the and then practicability is looking at the alternative measures and is it feasible? Is lockout feasible? Is it viable? Are alternative methods feasible or viable? You give that consideration. Then look at the potential alternative methods. We haven't gotten to one yet. There's a systematic approach to all this that's really important. And this is kind of a go, no-go stage, as the standard refers to it. It starts with this practicability analysis. In the back of Z244.1, there's actually Annex L, which has a good example here. And you can, for the sake of time, I can't really go through all this, but you can see through here that, it's looking at the number of shutdowns per day. It says, man, we got to shut this 4 times a day for 5 minutes. And and then problem is, we're fast cycling. So there's wear issues related. So you go through and you look at the safety, on the equipment, the financial impact, all those areas. And this sheet gives you a nice guidance for that. After we've looked at the practicability analysis, we've done that. The next risk assessment. Now, when you apply an alternative method, you'll see that this well-recognized industry standard, ANSI, ASSP, American Society of Safety Professionals, Z244.1, 2016 says, the method to lock out or tag out shall be based on a risk assessment that identifies the hazards. So sometimes I still get in discussions with folks, do I need to do a risk assessment? There's only one answer. Especially if you're using an alternative method, and it's yes. Okay, so keep that in mind. And this is really important. You get the team together. Alternative method deals with well-known hazards. Well, one of the benefits of going through a risk assessment is you kind of dig out all the potential hazards, and what you'll find is there may be some that you didn't even recognize before. So this, systematic standards-based approach to risk reduction is really important. And starts with identifying those tasks. Another thing from the risk assessment is, or to keep in mind, is that there are many risk assessment methods and models, and that's not choose one. Okay, certain industries like robotics. If you look at the Robot Industries Association, they have very nice guidance in their technical report. But what's nice is you can use that model for risk assessment on a lot of different equipment. You just wouldn't use the pieces that are specific to robot application. So, don't stress about which model, but choose one and use it consistently. And they actually called out, I think this is fair. It's a qualitative estimation. We want to be as quantitative as we can, but the reality is risk assessments, because they involve people, do still have a very high qualitative measure. So we see here's the risk assessment process. This is very normal. Starts with the look at the machine limits. You identify task hazard pairs. So what you want to look at is performing this task. The operator is exposed to this hazard. And the way a maintenance person may have to interface with a hazard. Look at the task hazard pair. Then use a risk scoring system. We'll look at one of those in a moment. Use the hierarchy of controls to systematically reduce the level of risk to an acceptable level. Okay, and then you assess, hey, is this a acceptable level of risk or not? If you're at an acceptable level of risk, you document, validate your solution, and move on. If not, it's an iterative process. You apply a risk reduction strategy and then put it back through the process. A couple other pointers here. Always at the end, ask the question, of course, my risk reduction effort, have I potentially introduced any new hazards? Especially if you've installed fixed guarding, something like that, you could create a pinch point or something. So here's some guidance, but we could spend all day just on this topic. Also, the risk scoring system here is a very common one. You see the RA 15.306. This one provides, all the models, risk scoring systems have that element of severity and frequency of exposure. Okay. So you got severity and probability. Those are the two elements of all risk assessments. And what they do is they help you get to quantify, get to the scoring system so that you can determine whether you have an acceptable level of risk. Now, if you let me go back up here. If I've gone through and I do not have an acceptable level of risk, say it's high or very high, and now would use the hierarchy of controls to systematically reduce my risk. First, I'd see, hey, can I eliminate or substitute or design it out? Then I look at guarding, fixed guarding. Then, at each level, I have residual risk that I carry to the next as I go through it. Once I've reduced risk as much as I can through design change elimination, guarding, and safeguarding, then I look at awareness devices. Then I go down to training and procedures, and then obviously the lowest level is PPE. But this is, a systematic way of getting down to an acceptable level of risk, and it's important that you follow these steps in this order. Simple example here. Obviously, with that spoked wheel, I have could be a pretty serious point there. Simple design help. Follow it up. So always look and say, is it possible just to design this hazard out completely, eliminate? A lot of different ways. Then you get into guards, safeguard devices, and you've got fixed guards, you've got movable separating guards, you've got non-separating guards, fixed position, and fixed process. Fixed guards, pretty straightforward, you see here. Practicability. One thing I kind of just dropped the note here. When you use fixed guarding, use the term auto. Look, does it, around, under, through, over. Is it possible to reach the hazard by going using the auto test? But it's permanent, it's guarded there. Now, fixed guarding is if I need access, that's problematic. Then I can't be removing guards and use the minor servicing exception. Okay, so then we get into movable guards, that are separating or non-separating protective devices. See, if you notice here, I achieve the objective. So once I've looked at fixed guards, say, no, I need access. Well, then I look at, could that be done with separating guards? Well, it could be, but if the person has something in their hands or they're going in there literally every few seconds, multiple times in it even, oh, well, that's not very practical. And then I'm going to have maintenance issues and things. So then I may need to look at non-separating guards. So you systematically go through the process, and separating guards will not only protect those outside the guard from hazards, but they'll also contain the hazard. So it keeps people out, but it also has to keep the hazard in. It has to be able to contain the hazard. So keep that in mind. Non-separating guards will not protect you from any falling or discharging objects. Pretty obvious. Just keep that in mind when you're going through your evaluation. You see here is a simple movable, guard interlock to prevent access. But here's a present sense and non-separating strategy. Potentially, be just as better. There are guarding solutions that are based on a fixed operator position. One thing to keep in mind, you see two operators there. Okay, I need to have two hand controls. I need to have the proper both operators, and then I also have to have a discipline to make sure that nobody else comes in to help out and things like that. So when you're looking at fixed operator position, you need to go through that one very, very carefully as an option. And then there's also fixed process conditions, such as reducing the speed or the direction or the amount of torque that's applied, force. So after we've done, the practicability and justification analysis, we've done the risk assessment, the alternative methods have to be evaluated. And man, if you ANSI Z244.1, don't let this overwhelm you, but it is significant. They have outlined some very important and specific areas that are ways you need to evaluate your alternative method. One is obviously industry best practices and methods, and you can find those in your C-level standards for the type of machinery you have. They're very, very useful for that. Architecture and structure. Okay, if I have a high level risk and I'm using devices and controls, they will have to be designed in a specific architecture or structure that provides the fault tolerance that you see down here that I need. The application of well-tried components and well-tried safety principle design. Evaluating our susceptibility to common cause failure. Oh, this is a good one. This one gets, man, to me, this one gets down to just good engineering and good workmanship. Am I using proper spacing in my panels? Do I have control signals and power separated? Am I using the right kind of current limiting devices? You're saying, well, that's obvious. Well, so many times, I mean, it just reinforces that you can buy a lot of the red stuff and put it all together, but if it's not sitting on the right foundation around it, it's not in the right environment rating and things of that nature, it can all be compromised. A topic that's really important, and I'm seeing a lot of adoption series like the exclusivity, individual control, really important that wherever possible we use that. Tamper resistance, if I'm using devices, make sure that they're installed in position so it's not easy for someone to tamper with them or bypass them. And then for the proper procedures, periodic checks, and then using qualified persons to review your work. That outside opinion. It's interesting. I've involved with a customer where OSHA has asked them to make sure that they have a review from a qualified person that the alternative method that they're using is adequate. They didn't use effective, but there. So I actually saw that show up in language conversation with OSHA field representative. So when we get to these alternative methods, the circuit performance, this architecture, structure, fault tolerance is real important, and that's it gets into circuit performance, which is a whole another deep topic. But remember, circuit performance involves the input, logic, and output, all those elements. You can't just meet the criteria for the input device. You have to meet all three elements have to meet the circuit performance requirements when you're doing the evaluation. So picture, it looks pretty safe. That's a nice looking red Rockwell Automation safety interlock switch guard locking. It looks like it's fairly well installed. Is it? Well, it may or it may not be. Unfortunately, if we look at the panel to which it's wired, no, it's not. I mean, there's not a safety rated device in all of that. But what's disturbing is lack of what I would call workmanship and adherence to NFPA 79, which is your on-machine panel standard, which is a safety standard, by the way, is important. No, even if I have this showing, if this is what's behind it, I've not met the criteria for that. I'll show this out for reference. When you get into circuit performance, ISO 13849-1 and -2 are really, really helpful and important documents. They criteria for circuit performance levels and diagnostic coverage, which are important parts of this. Let's kind of go through a case study here with a printing press. We're doing roll cleaning on a printing press. And what we have here, I'll kind of jump to, we've got an in-running nip for roll cleaning. Watch here, it's fairly short. You can observe, you'll probably also know, oh, that panel's wide open. There's lots of issues going on here. Lots of things I don't feel comfortable with. But there are two, one that the tasks I want to really focus in on. And that is the operator on the left that's facing the roll section there on the press. And he's getting ready to perform a roll cleaning task. Now, could this be covered under the minor servicing exception? Well, it may be. If it's done during normal operation, routine, repetitive, integral to the operation machine, we provided an effective alternative means of protection. We look at the practicality justification analysis. This is a little more specific. Assess the lockout impacts. What's the downtime? Are the lockout tasks so onerous, so complicated that we're really incentivizing people to bypass the procedure? And you know that if it's happening, that's a red flag. So that are we exposing folks to arc flash hazards? And then options for minimizing the exposure. Things like could we change the press settings? We get built up on this. Maybe we should use different ink, or maybe if we change the speed or the pressure between the rolls. You look at everything. Are there other options that would reduce the need to clean the rolls altogether? Could we eliminate that? But unfortunately, when we do the practicability assessment, if you've ever worked in printing, you know that this is inherent to normal press operation. So we've gotten through here. We meet all the initial criteria, but we need to look at potential alternative methods. We've done the risk assessment. That's part of looking at alternative methods here. With task, we've got the risk assessment. We got the rollers are being cleaned during every shift. Okay, it's critical to the quality of the product produced. The hazard is an in-running nip. Now, using this risk scoring system, I'm going to kind of get to the rest of it here. If you come up with anything other than very high, I'm worried, because this running nips on rolls are very dangerous. Okay, so my risk scoring this would be very high. Okay, which is not acceptable. Because it's not acceptable, now I need to go through the hierarchy of control for risk reduction and look at elimination, substitution, all the various options for risk reduction. I do not get to skip from A to F or A to E. I have to start at A and evaluate each one and ensure that I've done everything possible at each level before going to the other. And at the end, make sure I've documented any residual risk that's covered. So can I eliminate it? Can I make a substitution? Can I limit the interaction? And the reality is no, in this case. Make sure we document. So let's look at fixed guarding as a potential option here. Fixed guarding would would separate us from that in-running nip, okay? Problem is, we need access. We've already determined that. So it's not a viable option. What about interlock? Well, watch this video here in interlock. This gives us access with a movable guard, but what do you notice once it's open? Yes, the rolls were still turning. The hazard was still present, okay? And that's not going to be acceptable. What about, oh, guard locking, okay? This could be the trick, okay? So now the operator will initiate a request. This one's going to be time-based. You know, there's other techniques where you could feedback from an encoder and things like that. But now we don't have access until the hazardous motion is stopped. Good. But one of the things that concerns me is, see where this operator here? Do they have good visibility? You know, if somebody's standing over on this side, I still personally, I would not be comfortable with this, because the way the operator is interfacing the machine here, this is not sufficient. I don't feel that the person going in there would have adequate control. You can see here they could restart the machine. What about trap key? Now we're giving somebody exclusivity control. Request is made. Motion stops. Trap key allows us to release personnel keys. And now, while the person performing the cleaning task is inside there, they have the key with them. So it'd be impossible to restart that machine. It'd be have an unexpected startup with this scenario, as long as we've met all the other criteria for the circuit performance. The other way, we talked about fixed process condition. Now, fixed process condition is where technology is really helping us. You can see here we're making the request, but now we're going to affect the speed and direction of the rolls. So now, before their access is permitted, the rolls are reversed, which helps make the task go by faster. The speed is reversed. And now, when upon exit, they can start the machine. So generally, you need to look at all the options. A lot of times, you come up with a combination. You may feel most comfortable with a fixed process condition and a trap key. You know, it's not uncommon to see them put together. We just kind of get you to think here about those. So fixed process condition involves an entire system, as you can see here. Remember, if we use a circuit, the risk assessment is going to tell us what that circuit performance must be. It's not an effective measure if we don't design a system that meets that circuit performance requirement that'll be driven out of the risk assessment. This is absolutely critical. And so you can look at the alternative methods. This, once again, ANSI 9 is a reference here. And from our earlier example, you know, hey, are we justified in the minor service exception? And given the technology that we saw, I believe we could design a combination of measures that would be effective and allow us, in this situation, a combination of guarding. So I've got fixed guarding on the sides, but I've got a point of movable guard access. And then I could use a personnel key, like a trap key, along with fixed process conditions, to come up with an effective measure, be able to justify it. Now, for the sake of time, I'm going to summarize what's here, but this comes right out of some of the OSHA training. And if you haven't used the OSHA resources for lockout or tagout training, man, they've got some awesome stuff out there that I reference all the time. And, you know, it doesn't cost anything. But in this case here, we have a situation where the printing and press roll has to be cleaned. And, you know, as we read through this, we see, oh, there's a hazard. There's an ingoing nip. And we can see what the company decides. The printing press is energized and its rollers continue to spin at a very high speed. In order for employees to clean the rollers, they must bypass, ding, ding, ding. You see that word, bypass? That should be an alarm or a red flag. The printing presses machine guards and use rags to clean the rollers. This exposes them to serious and going nip hazards created by the rollers, so forth. Although the employer has a lockout tagout program for servicing or maintenance of the printing press for this particular cleaning operation, the employer believes that lockout or tagout procedures do not need to be implemented. Okay, pretty common scenario there. Unfortunately, they've looked at the normal production, routine, repetitive, integral to the operation. They've looked at that. Alternative measure, we'll see. So question is the printing press roll cleaning activity covered by a lockout tagout standard? And the answer is yes. And tells you why. Well, even though the roll activity takes place during normal operation, as we see through here, you'll find that the employee is placing their body into a point of operation associated with a danger zone. Employer argues that the roll cleaning activities are routine, repetitive, integral to the production of the operation. The lockout is, and that lockout is not required because the minor service exception is described. And that 147 is applicable. Is the employer correct? The answer is no. Why are they not correct? Well, the reason they're not correct is summarized here. They've not provided or implemented an alternative measure, an effective alternative measure protection for the task. And they are bypassing, you see they bypass the machine. Bypass is no. So if you're bypassing, you're doing something wrong, okay, in this regard. So, but I point out here what's in red. In summary, for the minor servicing exception to apply, each and every element of the exception must be met. All elements. It's an all or none proposition. Okay, in this case, the work is not performed using alternative measures that provide effective employee protection. And unfortunately, what I've seen way too often is folks get the normal production, routine, repetitive, integral to the operation machine, and placing it all light curtain is an alternative method that's effective. No, you don't get to jump to there. There's a means, using guidance from Subpart O, from industry standards like or ASSP Z244.1 that help you derive that and determine that you have developed an effective alternative means or method of protection. Finally here, this is pointed out, I want to make sure I touch on this, is that change management is very, very important. Your safety functions need to be protected. Hopefully your organization has an approach for change management, but especially when it involves any pieces of safeguarding safety function, you've got to do the reviews. It's absolutely critical because in one moment, it can all be unraveled because someone thought, well, this is a drop-in replacement for that, and they didn't look at they didn't evaluate all the specifications carefully. Things of that nature. So make sure it's real key to preserve everything that you're doing in this area that you have an effective change management program supporting. So a couple additional useful references. Go out to Google and you Google OSHA Directive CPL02. You don't even have the rest in there. You'll find some really good policy information. And then a really informative permanent variance document is the Nucor Steel Grant of a Permanent Variance by OSHA, and you can Google search that and find a lot of good information on there. So with that, I conclude the formal part of the presentation today. I have some questions here and some dialogue, but if your question doesn't get answered or you think about it later, make sure that you use the email address that the McNaughton-McKay folks have provided here at mclive-mc.com. So with that, Rachel, I'll turn it back over to you.
Thank you, Tom. We do not have any live questions in the chat at this time, but I'd like to open the floor now to anyone that does have any questions. And just as Tom said, Please feel free to send any questions you might have after the fact, or if you're watching this recording and you have some questions, just reach out at mcmclive@mc-mc.com, and please mention the session that you attended, and we'll make sure that your question is sent to Tom and he can respond to you directly. We'll give just a second here for anyone that might have any follow-up questions. All right, I want to thank you, Tom, and thank you, Jim, out in the comments. This was a wonderful presentation. We also want to thank our audience members for joining us today. We hope this session was informative and engaging for you. We look forward to seeing you again. Please remember to subscribe to the McNaughton-McKay YouTube channel and join us again next week for another live session. Thanks again. Have a great day.
Thank you, Rachel.